Evaluate the limits if possible. When determining limits of functions of two variables, we use the techniques listed below in the following order. Number 1, we try to perform direct substitution, which works if the function is continuous around the point we're approaching. If when performing direct substitution, we have an indeterminate form, we go to step 2 and use algebraic techniques to try to simplify or change the form of the function so that we can then perform direct substitution to determine the limit. If neither of these two techniques work, we need to approach the point from different paths. To begin, we have the limit as x comma y approaches 1 comma 1 of the rational function, the quantity 6x to the fourth minus 6y to the fourth, all divided by the quantity 2x squared plus 2y squared. Because we have a rational function, we're mostly concerned about division by 0, but notice because we have 2x squared plus 2y squared, there are no values of x and y in which the denominator will be 0, and therefore there are no domain restrictions, and the domain would be the entire coordinate plane, or R2. This indicates we can determine the limit by performing direct substitution. The limit is equal to the quantity 6 times the fourth power of 1 minus 6 times the fourth power of 1 divided by the quantity 2 times the square of 1 plus 2 times the square of 1. Notice we simply substituted 1 for x and 1 for y. Simplifying, the numerator is 6 minus 6. The denominator is 2 plus 2, giving us 0 divided by 4, which is equal to 0. Before we take a look at the second limit, let's look at the graph of the function. Here's the graph of the given function. It is continuous over its entire domain. As x comma y approaches 1 comma 1, we're approaching this blue point on the function, and this blue point is 1 comma 1 comma 0 on the surface, verifying the limit is equal to 0. Again, as we approach this point from any direction, we are approaching the y value or function value of 0. Now looking at the second limit, the only difference is now we have a difference in the denominator. But now if we perform direct substitution, we have the indeterminate form of 0 divided by 0. So now we'll try to use some algebra to simplify out the discontinuity. Let's try factoring. Let's begin by factoring out the greatest common factor of the numerator and denominator. This gives us the limit as x comma y approaches 1 comma 1 of 6 times the quantity x to the fourth minus y to the fourth, all divided by 2 times the quantity x squared minus y squared. Notice we have a difference of squares in the numerator and denominator. Let's go ahead and factor further. Factoring the numerator, we have 6 and then times the factors of x to the fourth minus y to the fourth would be x squared plus y squared and x squared minus y squared. Now we need to be careful here. We don't want to get in a hurry and factor x squared minus y squared, because if we did, we would miss out on recognizing the common factor of x squared minus y squared between the numerator and denominator. We will leave the denominator as 2 times the quantity x squared minus y squared. Now in this form we can simplify. X squared minus y squared divided by itself simplifies to 1. We can also simplify 6 divided by 2, which simplifies to 3. The given limit is equal to the limit as x comma y approaches 1 comma 1 of 3 times the quantity x squared plus y squared. And now we can determine the limit by performing direct substitution. The limit is equal to 3 times the sum of 1 squared and 1 squared, which gives us 3 times 2, which is equal to 6. Let's also verify this graphically. Here's the graph of the given function. It's hard to tell, but the graph does have discontinuity. We can kind of see some gaps in the graph here. But again, by factoring and simplifying, we were able to remove the discontinuity and perform direct substitution to determine the limit. So looking at the graph, as x comma y approaches 1 comma 1, we're approaching this black point here. This is the point 1 comma 1 comma 6, which does show as x comma y approaches 1 comma 1, we are approaching the function value or z value of 6. I hope you found this helpful.